We know that Charles' law is given by this formula, T1V1 equals to T2V2. All this means is if the temperature doubles, the volume will double as well. But you might wonder, how did they come up with this formula? The way scientists come up with formulas is by doing experiments. This experiment will need a balloon, and we're going to measure the temperature of the balloon and how big the balloon gets. So what we will do is we will take the temperature in Kelvin, of course, and measure the volume of the balloon in liters. Okay, so let's say the temperature is 73 K. We will put this balloon in a 73 K environment, and we're going to measure the volume. Let's say the volume is 0.7 liters. We'll take the same balloon and we'll heat it up to 173 K, and the balloon becomes bigger, 1.7 liters. Okay, then we take the 273 K, we heat it up, and it became 2.7 liters. And then we take it to 2.7 liters. Now, if we want a balloon to get to 3.7 liters, can you predict what the temperature would be? Okay. Yes, you can. You can use the data that you've had before and see if there's a trend. It looks like 73, 173, 273. So I predict that to be 373 maybe. Okay, and then because it's going up by 1 liter. So that's our prediction, but sometimes the numbers are not this nice. So what we do is we take this data and we plot it, and by plotting it, we'll get an equation of a line. So here, let's plot this data. So we have 73 K, here's the temperature on the x-axis because that's what we're changing. That's the independent variable. So 73 K is about right here, goes to 0.7 liters, so that's the first balloon. Then we heat it up to 173, 1.7 liters, 273, 3.7 liters, and that is our data. Okay. If we wanted to know what happens at a higher temperature, we can take this line and extrapolate or extend it. Okay. Another way of doing that is just find the equation of this line, which is equal to y equals mx plus b. Find the slope and see how it changes. So let's go ahead and look at this equation. Y equals mx plus b. On the y-axis is the volume. So we're going to put volume here equals the slope. And the x-axis, what's on the x-axis? That's right, temperature. That's T. And the y-intercept is 0, so this will be 0. So this is the formula, V equals mt. Okay, to get the slope, we divide both sides by T. V over T is equal to m. That's the slope. So as you notice, the slope here is the same as here, 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 and here. The slope is not changing. So this m will never change. It's constant. So this is like maybe V1, V2. What if I wanted to go over here? Okay, that could be another V over T. The slope there is always the same. So this could be initially, and this could be in the future. What would it be? Since the slope is the same, they're equal to each other as well. Since they're equal to m, then this and this are equal to each other. So V1, T1 is equal to V2 over T2. And this is where Charles's law came from. It came from experimentation. Okay, so how do you use it? Well, all we have to do is take one of these data points as your one. You can pick any one of them, it doesn't matter. Let's say this could be the initial condition. Okay, so you plug it in. So V1 would be 0.7, liters, and then T1 would be 73K, equals V2 would be 3.7 liters. And what you're doing is you're just wondering what would happen, what would temperature be. This is X. And this is that question mark right there. And we predicted about 373, okay? So to solve this problem, a lot of students, what they will do is divide by 3.7 on both sides. That's absolutely wrong. If you do that, you will get 1 over X. The easiest way to do this is you want to cross multiply and divide. So I'm just going to do this. I'm going to drop the units for now just to make it simple. 0.7x, 0.7 times x is equal to 73 times 3.7. 73 times 3.7. So cross multiply. Okay. After you do that, you can divide by the 0.7. Okay. Let me grab my calculator. So you have 73 times 3.7 divided by 0.7 equals 386. So X is equal to 386 kelvins, which is pretty close to what we predicted. Okay. So this is which is okay. So this is how we just derived Charles's law, and this is how we use it. And by the way, if you look at all the other gas laws that are directly related, so if you look at this one is direct, this one's also direct, this one's also direct, all of those 3 equations are derived the same way as Charles' law. Okay, they do experiments, they plot it, and they make an equation of a line, and then use that for the formula. Now we're going to derive the equation for the only one that's inversely related, and that's Boyle's law. For the next video, we'll do that.